I think we start now. So good morning, everybody. I hope you're not sleeping or dozing anymore after the great keynote. Before I start, I'd like to introduce myself a little bit. My name is Ralf Wondratschek, and I work for a company called Evernote. If you haven't heard of Evernote yet, it's basically a note-taking app, but of course provides a lot of more features on top of that. Evernote is based in Redwood City, that's a bit south of San Francisco. And if you haven't seen any screenshots or the app itself yet, those are two impressions of the app. But now let's get back to the topic, those. The reason why I'm standing here today is probably this little icon. Nobody likes to see it, and it always appears at the worst time. And the reason for that is not only that devices nowadays have too small batteries, but the other reason is also the implementation of the apps. We as developers can do a lot to avoid that the battery runs out so fast. And one of the reasons why the battery is running out so fast is repeated work. I think every app out there has some kind of repeated work that it needs to do over and over again. May it be the popular synchronization job or a cleanup task or anything like that. Here, we can be really smart and avoid a lot that the battery is running out so fast. Then Google was also aware of the problem. That's why they introduced with Android Marshmallow 2 new power savings modes called Those and App Standby. And those also had implications for our apps. And we need to be aware of those power saving modes and implement our apps properly. Then, a few weeks ago, Android O was released. And Android O is even more strict than that. And probably making your app ready for Android O required to do some cleanup and changes inside of the application. But let's go a little bit back in time and start with those and App Standby. I could tell you many things about those, but I think this slide is describing best what's happening with those. So the typical use case is that you use your device, you have it in your hand, the screen is turned on, and you're interacting with some apps. After some time, you turn off the screen and put the device on your desk, and don't move it at all anymore. What happens with those is that after some time, like you can see here, a those window starts. And there, the Android system is not only reducing the CPU frequency, but it also doesn't allow to run any apps at all. After some time in the those window, a maintenance window starts. And here, the system looks for applications which need to do some work, and it starts those applications. And after they are done with their work, the device goes back into the those mode. And there, it saves a lot of battery. The those windows increase over time, and this continues until the user turns on the screen again or maybe picks up the device from the desk. So with Android 6, the those mode was introduced. Then with Android Nougat, a new mode came into play. That's the those light mode. And the those light mode already starts if you turn off the screen and put the device maybe in your pocket. On the other side, the those mode was really effective for devices which you don't use that frequently. For example, tablets. You use it in the evening, you turn off the screen, and then you use it the next day again. And of course, during this time, the device shouldn't use that much battery. And this has significantly improved. And the third power saving mode is App Standby. App Standby is intended for apps which you don't use that often. Let's say you install a game, you play the game, and then you don't use the app at all for 2 weeks. Of course, during those 2 weeks, the app shouldn't run or waste any battery at all. Of course, there are also some edge cases where the those mode shouldn't be allowed to run, and you have the option to interrupt the those mode. One very important example is, for example, high priority GCM or FCM messages. So if you receive a notification in one of your messenger apps, you want to see the notification immediately and not maybe 15 minutes later. And of course, there's a longer list of things which can interrupt the DOS mode, and especially the APIs, we will come to them later. Okay, so a few weeks ago, Android O came out. And Android O came with the biggest changes, in my opinion, for a long time. And one of them are the background service limitations. We always knew Android for the fact that one app could run in the foreground, the user is interacting with it. But in the background, other apps are running and doing some background work, like syncing data or whatsoever. And this doesn't work this way anymore. Google is now recommending to use foreground services. A foreground service is like a background service. It's doing something in the background, but the user has a visible indicator. For example, the user could see a notification on the screen, and the user is aware of that your app is doing something in the background. And the recommended way to do background work now is to use a foreground service. On the other hand, if your application is already in the foreground, a screen of your app is visible, then you don't need to use a notification. Instead, you can use a normal background service as usual. But the system is now more aggressive and kills your application if the user is leaving your app. So the way you should do it here now is to switch to a foreground service again if the user is leaving your application. And last but not least, it's not allowed anymore to start a background service from an application which is currently in the background. Instead, you receive now an exception, and the service won't be started. The second big change is that they removed a lot of broadcasts. And the way they did this is not only that they removed broadcasts, but they introduced a whitelist. This is really important to keep in mind, because they didn't disable just some broadcasts. No, it's the other way around. They just allow some broadcasts nowadays, and others don't work anymore. For example, the popular connectivity change event. In the past, what we did, if our app required a stable network connection, then we added a broadcast receiver in our manifest file and listened for this event. And if the network was connected, then we did our background work. This doesn't work anymore. Broadcasts which are listening for those removed broadcasts don't receive a callback anymore. Instead, what you have to do, you can still programmatically listen for broadcasts, but it doesn't work with the manifest file anymore. And I'd like to show you one little workaround, because this hit us in our app as well. We have an auto code base, and we have a lot of our own intents inside of our application. For example, if the user creates a node, then we send a new node intent, and broadcast receivers are listening for this change and then doing some work. This stopped working with Android O, and what we did, we introduced our own permission, and our broadcast receivers acquires this permission automatically. And when we send broadcast, then we send it with this permission. So only broadcast receivers with this permission get notified. And this was a workaround for us. It worked for now. But if you have the time to refactor your application, then it's better to move away from broadcast receivers. Now let's get to the APIs to work nicely together with the power-saving modes, so that the user benefits from it in the end. And I think it's always the easiest way to do this with an example. So let's create a little reminder app. The requirements are really simple. The user can create reminders in the application. After some time, we want to notify the user about the reminders. And of course, we want to sync those reminders with a server. In the end, we want to implement this as effective as possible. And of course, we also want to support all devices out there. It's a really simple app. So why shouldn't we support all of them? Let's start with the reminder job. The reminder job must be exact. That means we want to show a notification to the user at a given time, not 5 minutes earlier or 10 minutes late. We want to show the notification at the exact time. Then we can have multiple reminders. So we also need to have multiple reminder jobs in our app. And the correct API to use this is the Alarm Manager. I will show you all the APIs which we have to do some work on Android in the future. I will quickly run over them. You don't have to remember everything, but I just want to see you how painful it is on Android to implement all those tasks. Okay, let's start with the Alarm Manager. The good thing about the Alarm Manager is it's basically exists since version 1. So the code you will see in a second, this would also run on the very first Android device. And it's really easy for the broadcast receiver to send a broadcast or to start a service in the future. The downside of the alarm manager is that the API behavior differs between platform versions, and you will get some unexpected results. And in the end, you have to write a lot of boilerplate code to do something simple. OK, first thing we need to do for our reminder job is we create a broadcast receiver. That's really simple. In the end, we create the broadcast receiver and implement the onReceive method. That's nothing fancy here. This is really basic Android stuff, so we skip this. More interesting is how we schedule the alarm in the system. And the first thing you need to do, since we are sending a broadcast, we create an intent. Then we wrap this intent inside of a pending intent and pass this pending intent to the alarm manager. One thing I'd like to point out here is how the system compares pending intents. For example, if you want to later cancel the alarm in the system so that the system doesn't send this broadcast anymore, then you have to create the same pending intent again. And pending intents are treated as equal if the component is matching your targeting. So in the end, we would have to target the same reminder receiver again, even if we removed it. And the request code is the important part as well for the pending intent. Those have to match. On the other side, the extras inside of your intent, they aren't compared. So they could be different, but the system still would treat them as equal. And in the end, we set the pending intent inside of the alarm manager. OK, let's say we released this application 4 years ago, and this perfectly worked fine. And then Android KitKat came out. And our app stopped working as we expect to work. And alarms were sent delayed, or notifications appeared too early. And the reason for this is that Google changed the semantics of the set method. Before that, alarms were always exact and were sent at the correct time, which we passed in. Now, they are inexact. And as a workaround, they introduced another method called setExact, which we need to use because our reminders need to be exact. This worked fine again. And then Android Marshmallow was released with the new power savings mode, DOS, for example. And the same thing happened again. Our notifications appeared too late if the device was turned off and was currently in DOS mode. And we have a third method now here. And this one is called setExact and allow while idle. So allow sending this alarm even if the device is currently in DOS mode. And that means in the end, for our simple reminder job, we have something like this. If you're on Android Marshmallow or above, use the setExact and allow while idle method. Otherwise, use the setExact method. And if you're on an older device, use the old set method. And Google was also aware of this problem, that this can be really confusing. And that's why they released this flowchart to describe the API. But honestly, if you have to describe an API like this, then it has failed. And there should be a better alternative. In their defense, this alarm manager exists since the very first version of Android. And yeah, requirements have changed over time. But nonetheless, there should be something better. OK, that's the reminder job. Now let's get to our sync job. The sync job should sync our reminders with the server. So we have other requirements here. The first thing is that our sync job doesn't need to be exact, like the alarm manager. So we don't want to unnecessarily wake up the device if we don't need to. On the other hand, the sync job must be repeating. So we only need one, but this one needs to run over and over again. Then another requirement is that the sync job should only run in an unmetered network and only while the device is charging. And not only do we want to be nice and save battery for the user, but we also want to save actual money for the user. We don't want to sync our reminders if the user is in a roaming network, and we would create costs for the user. And the correct APIs which we have here are the job scheduler and the GCM network manager. So let's take a look at them and start with the job scheduler. The job scheduler is an easy-to-use API. It's fluent. It looks much better than the alarm manager. It respects the device state. So we can set certain requirements, like that the device must be charging. The problem of the job scheduler is that it's only available on API 21 and above, and some features are only available with Android Nougat or even Android Oreo. And of course, there are platform bugs. So for example, there's a nasty race condition. It could happen that your job is started twice, although you scheduled it only once. So let's look at the implementation. I will also, again, go quickly over it. The first thing you need to do, we create a service in our manifest file. Something I'd like to point out here is that we are requesting a permission, and we'll see in a second why I did this. Then we have to implement our job service class. This is nothing fancy here. The only thing that's important is that the onStartJob method and the onStopJob method are called on the main thread. So if you are doing background work, which, for example, runs longer, then you need to spawn another background thread and do your actual work there. And when you're done, you need to notify the system that you're done with the work. Again, more interesting here is the schedule method, and it already looks much better than the alarm manager. The important part here is jobs are identified with an ID, so it's much easier for us to cancel the job later. We just need to know its ID and not create an impending intent and cancel it in the system. It's much easier now. Then, like I said, we can define certain requirements. In this case, we want to run the job only when the device is charging, and if we have a good network connection, which doesn't create any costs. In the end, we persist the job. And that's why I requested the boot completed permission. So if the device reboots, then our job is automatically rescheduled, and we don't need to do this ourselves. That's something we haven't talked about with the reminder job yet. So if the device is getting rebooted, then our reminders need to be rescheduled, and we have to do this on our own. Here, the API provides a simple method for us to do this. Then, with Android Nougat, a new setPeriodic method was introduced. Before that, we only had the interval parameter. The requirement for a periodic job is that it should run once during each interval. The flex parameter stretches the interval a little bit, and I describe here why this is important. Like I said, the requirement is that the job should run once during an interval. So it can happen that the job runs at the beginning of an interval and then during the next period at the end. So the gap between those runs is actually longer than our interval. And here the flex parameter is helpful because then it reduces the time frame for the job to run. And of course, we want to implement this as effective as possible. Then if we have the option, then we want to use the flex parameter. The problem of the job scheduler is that it's only available on Android Lollipop and above. On the other side, the GCM Network Manager is available since Android version 9, so basically all devices out there. And it's really similar to the job scheduler, and you will see this at the actual implementation. The problem of it, it's part of the Google Play Service SDK. That means you can use this API only if the Google Play Service are installed. In Europe or in the US, that's not a big deal. Most devices have the Google Play Services. But for example, in China, most devices don't have them. But we also want to support those devices as well. Nonetheless, we take a look at the implementation. And like I said, it's really similar to the job scheduler. So the first thing again, we create a service class, then we implement the GCM task service, and here we only need to override one method. It's a little bit simpler than the job scheduler, and this method is already called for us on the background thread. But that's not so interesting. Again, the fun stuff is in the schedule method. And the difference to the job scheduler here is that jobs are identified with a tag. It's just a little bit, it's not really that kind of a big deal, but it's different than the job scheduler. On the other hand, the setPeriod method and the setFlex method, they accept seconds. This is something that really has hit us. We used the GSM task service and didn't know why our jobs didn't run because we scheduled them years in the future because the API accepts seconds and not milliseconds like any other API. I don't know why they did this, but it's something to be aware of. And that's it for the GSM task service. So again, job scheduler is only available with API 21 above. Below that, we use the GCM Network Manager if the Google Play Service are installed. And as a fallback, then we have to use the alarm manager again if those APIs aren't available. And we skip this here, but I promise you it's as much fun as it was for the reminder job. So overall, for our sync job, we have something like this. If we are on Android Nougat or above, we use the job scheduler together with the flex parameter. If you're on Lollipop and above, then use the job scheduler without the flex parameter. Below that, use the GCM network manager. And if the Google Play service aren't installed, then use the alarm manager as a fallback. So for the sake of completeness, I'd like to mention two other APIs. One is the Firebase job dispatcher. The idea of the Firebase job dispatcher was that it's a wrapper around the existing job schedule engines, which I described earlier. The problem of it is that it's really difficult to set it up properly. The library is not maintained. Then right now, it only supports the GCM network manager. So the Firebase job dispatcher is only a wrapper around the GCM network manager at the moment. And it has the same requirements like the GCM network manager. So the Google Play services need to be installed. And because of that, I wouldn't recommend to use it at the moment. Then with the support library 26, we have the new job intent service. The job intent service is really meant as a replacement for the intent service. So the intent service is a service you send an intent and you do your background work. And the good thing about the job intent service is that it respects the state of your application. And on Android O, this means you can start a job intent service even from the background, and you won't receive an exception because the job intent service in the end on Android O will use the job scheduler for you automatically. Another nice benefit of the job intent service is that it handles wake logs for you, so you don't have to worry about that the device goes into a sleep mode and your application stops. It's not really a job scheduler engine. It's really meant only for running tasks now on a background service. So you cannot, for example, wrap the intent inside of a pending intent. It's really just start the service now and you're done. Nothing more on top of that. And for example, once the job is enqueued, you cannot cancel it anymore. So in the end, we have to write a lot of boilerplate code for something that should be easy to implement. Like doing something in the future, it's a common task. And I think every app needs to do this. And to implement this as effective as possible, we have to implement different APIs, which are different. We have to worry about on which thread those callbacks are called, and so on and so forth. So it's not really nice to use. And of course, if something like this is this difficult, there should be a better solution. And fortunately, there is a solution. We had the same problems at Evernote, and I implemented a library called Android Job, and it's doing all of this work for you. Android Job provides a single API for all the other existing APIs, and it's a wrapper around the job scheduler, GCM network manager, and alarm manager. It supports all API 26 features. For example, new requirements were introduced with Android Oreo. We all backported them, and it works on all devices out there. It automatically chooses the best API for you. So you don't have to worry about, do I need to use the job scheduler, alarm manager? You don't care. You use one API, and the library is doing the work for you. In the end, this means for you, you have to write less boilerplate code. You only need to do this once, and it works on all devices. And of course, there are other features like no reflection, it's maintained, and so on and so forth. So let's look at the features. Those are all of them, and we quickly go over them. The first thing is that we map, or for our jobs, we need to tag to identify our job later. For the time requirements, we have 4 methods. For example, we can define a time window for our job if we need to run it only once. On the other side, if we need an exact job, then we call set exact, and the job will really run at this time. And you don't have to deal with all those different methods for the alarm manager. Then we can define a backlog of criteria. That's also something we haven't talked about yet. What happens if our job fails and we want to repeat the task maybe in 10 seconds, in 1 minute, in 10 minutes, and try the job again? That's really simple here. You just define a backup criteria, and then when your job failed, you tell the library, hey, try this again. And it will try it again. Then we can define certain requirements. For example, our device must be charging. We need an unmetered network. And we also have the features from Android O. For example, that our storage shouldn't be low. Those are all supported. Then we can pass extras to our job. And we also can use the real bundle. And I will talk about transient jobs a little bit later. On the end, we can tell the library to cancel all jobs. For example, for our synchronization job, we need to have only one job. So we say if we create a new job, then cancel the old ones automatically. This method does this for you automatically. And in the end, we call build and schedule this job. This one returns an ID for us. So for a job ID, for example, the reminder job, we could have multiple jobs. In the end, they are identified with their ID. And if you want to cancel a job later, you need to know its ID, or you cancel all of them. So how can we use the library? It's really simple. The first thing we need to do, we add the dependency. Then we need to create the job manager. And the best place to do this is inside of the application class. Once you created the job manager, you add a job creator interface. And the job creator interface is really just a mapping from your job tags, from your strings, to the actual job class. And it's doing nothing more. It's basically replacing the manifest entry, but it's more dynamic than that. So that's it. We only need the job creator interface and the dependency, and then we can start implementing our reminder job. And the difference here is that you extend the job class compared to the other APIs. And then you have one method to our right, and that's the onRun job method. And this one needs to return a result. So the onRun job method is already called on a background thread for you, so you can start doing your work right away. And the library is also acquiring a wait clock for you, so the system won't kill your application. And then, for example, if your job failed, you return here instead of a success result and reschedule result, and the job will run again at a given time later. More interesting, again, is the schedule method, and this one is really easy and simple. For the builder, we use our tag. Again, that's the tag which we later need to use in our job creator interface to map this tag to our actual job class. And then we call setExec on the job. And our reminder job really will run at this time and not later or earlier than that, even in DOS mode or on which device, whatever. And that's it for the reminder job. We can straight go to our sync job. This one is even simpler. Like I said, we are already in a background thread, so we can sync our jobs right away without any extra work. The schedule method looks a little bit more complicated than that, but really it isn't. So we go over it. The first thing I did here, since we need only one synchronization job, before I schedule the job, I look if I have already scheduled one. If one job is already scheduled, then I stop here and don't do anything. If we don't have a job yet, then I create one. And here I call setPeriodic. Again, the library supports all features, and the flex parameter was backported, so we can use it and don't need to make any changes for different API versions. After that, we call setUpdate current to true. Like I said, it's not really needed here because I did a check myself above if there's already one job, but just for safety reasons, if something goes terribly wrong, we cancel all jobs so that we really only have one synchronization job. After that, we pass in our requirements like the unmetered network and that the device must be charging. And in the end, we call set requirements enforce to true. The reason for that is the library is just a wrapper around the other APIs. And so it can happen that we need to use the alarm manager under the hood. And the alarm manager doesn't respect the device state. And it doesn't check, for example, if it's in an unmetered network or not. And This method is just a helper for you so that the library checks all those requirements for you automatically and don't even call your job if the requirements aren't met. And instead automatically reschedules the job for you. So since we need to have a good network connection, it doesn't make sense to start our job at all. That's why I'm setting the requirements enforced to true. And that's basically it. We are done with our sample application. It's really just those small pieces, and it works on all devices. So, for example, who's using the library? There we have some bigger names like Dropbox or Twitter, Pocket. Then the New York Times is using the library, and of course we do at Evernote. I often receive the same questions over and over again about the library, which are more about the internals. So let's do a little FAQ to answer those questions. And I think it's always helpful to understand how a library works under the hood. So the first question, which API is used? And it depends on your job. So if you have an exact job, then we will always use the alarm manager because simply there is no other API for that. If we are on API 21 and above, then we always will use the job scheduler. Below that, we will use the GCM network manager if the Google Play services are installed, and otherwise we will use the alarm manager as a fallback. What happens after a reboot? Then the library tries to reschedule your jobs automatically. And this needs to be done, for example, if the alarm manager is used. You don't have to worry about a thing. If you want to run a job, then we do all the work for you and reschedule it. And if you really don't want to run the job anymore, then you have to cancel it manually. And the same thing happens after a forced close. I don't know if you're aware of this, but if you force close an application, then all your alarms inside of the alarm manager are cleared. And it's really difficult to detect this and reschedule tasks if necessary. And the library is also doing this for you, also after the Play services are installed, because then you need to reschedule everything inside of the GCM manager. And of course, if your application was updated, then we also reschedule everything for you. My periodic jobs aren't running as expected. And the reason for that is that you always should keep those and the system in mind. The library isn't fighting the system. It tries to be nice to the user. For example, if you schedule a periodic job with an interval of 50 minutes and you expect that the job is really running at 50 minutes, then this won't happen. If the device is going into dose mode, then it will delay your job and run it later, either in a maintenance window or when the device goes out of the dose mode. So in this example, we could have a delay of 1 hour or even 2 hours. And although we said that our job should run every 50 minutes, it won't happen. And if you really require your job to run every 50 minutes, then maybe you should reconsider your requirements. In the end, this won't be nice for the user because it wastes a lot of battery if you stop the dose mode. How can I run an asynchronous operation? Like I said, the onRun job method is already called on a background thread for you. So if this method returns, then the library thinks that you are done with this job and you are not doing anything besides that. And if you're doing something in the background, then simply block this thread and wait until your background operation is done. When it's done, then you return the result, and then the library will release the wait clock for you and maybe stop the application. Or actually, the system will stop the application if it needs to. What happens if my job crashes? Crashes are treated as a failure. And for example, jobs aren't rescheduled if you return a failure result. And if you really need to reschedule your jobs, then you should write a big try-catch around your code inside of the onRun job method and return the proper result. But if you don't care, then you don't need to catch exceptions. Can I reuse my jobs? I don't know why, but this question comes up so often. Inside of your job creator interface, if you receive a callback, you should always create a new job and don't reuse any jobs. If you need to do some heavy initialization, and then you can do this inside of your onRun job method, which is called on a background thread. So no, always create new jobs. What are transient jobs? Transient jobs, this is a new feature which was introduced in Android O, and we also backported it. The idea is that you schedule a job inside of this job scheduler, and if your application is closed or terminates, then your job won't run. And one good use case for this is when you want to use a transient job is if you want to run a job now. Then you don't care if your application is killed 5 minutes later because you want to run your job now. And the reason why it's helpful to use the library instead of normal service here is it's handled the backup criteria for you, for example. So you can reschedule your job if it failed. On the other side, the job isn't written to the disk like with normal jobs. How can I run a job once a day? It's really easy. Use the daily job class. This is a little helper, and you instead of extending the normal job class, you extend daily job, and then it's a similar method which you need to override. The only real difference is here for scheduling the job, you need to use another helper method, and then you define the time. For example, this job would run once a day between 1 a.m. and 7 a.m. in the morning. How can I test jobs? The easiest way we found out to test jobs is with test options for our QA team. So our QA team wants to verify that background services are running as expected, and so we gave them an option to start them immediately instead of delayed, so that they have to wait. But of course, that sometimes isn't that helpful. Another way to test jobs or verify that you actually schedule them is to check the database. So we write all jobs to the disk into a database, and you can open this database and see if all requirements are set properly. And you can also see the job ID. And this job ID is important because, for example, you could trigger jobs with the job scheduler really easily with ADB. There's a command to fetch our jobs, and here is the output. So we see our job 1 and our job 2 are here scheduled as expected. And then there's a command to force run those jobs. And this would also trigger our job library and start those jobs. So that's a useful command. And then the last question, how can I test the dose mode? There are also two simple ADB commands. One is that you can force the device to go into the idle mode, basically into the dose mode, and then you can go out of this mode again. And you will notice that jobs aren't running when the device is currently in dose mode. So that's the expected behavior. And if you leave the dose mode, then those jobs, which should have already been run, they will start immediately after that. On the other side, if your jobs are exact, then you will see that they run even in dose mode. So you can test this behavior there as well. And that's it. Some last tips and tricks about the job library. They are really helpful samples, and you should look at them and take a look at the README. Then there's an FAQ with even more questions if you have problems. And if you're still uncertain and can't solve your problem, then feel free to create an issue, and I try to help you as soon as I can. So what we've learned is that the Android APIs, they force you to do the same thing over and over again for multiple APIs. You have to write a lot of boilerplate code, and here, really, the Android job library comes to the rescue and does all this heavy work for you, and you can really focus on your task. Thank you very much. Are there any questions? I think there's a microphone. I'm not sure if you need to use it, but feel free to ask it.
How does the sync adapter fit into this?
We don't use it because the question was, how does the sync adapter fit into the concept? And we don't use the sync adapter at all, also in the library, because the sync adapter has other limitations. For example, a sync adapter is similar like a periodic job in the end. It should do its task over and over again. And for this, we simply use the job scheduler. And the sync adapter has other limitations, like a job wouldn't be able to run every 15 minutes. I think for the sync adapter, there's a delay of 1 hour or something like that. And yeah, that's why we don't use it at all.